So the whole start of second semester is trigonometry. Now, if you just came from a trig class, a lot of what we do, like the first day of each new topic, will seem very familiar, but then we'll often build on it, okay? If you haven't had trig, it was last year, and some of the topics were just touched on lightly in Honors Algebra 2. This is scary, but if you had regular, no, this shouldn't really apply to any of you. The right triangle trig, if you had geometry 2 years ago, this is a topic in geometry that was taught at the very end. So it would be when you were in quarantine 2 years ago and didn't have to do anything in the spring. So we'll see how this goes. I hope it sounds familiar to most of you, but let me know and we can go over some stuff a little slower if we need to. The learning targets today are to just find missing sides and angles in right triangles using, I hope this looks familiar to some of you, sine, cosine, and tangent. Does that look a little bit familiar? Okay. And then also find exact values of missing sides and angles in 30, 60, 90, and 45, 45, 90 triangles. All right, there is a little note down here that this is a theta, a Greek letter theta that we will use a lot starting even today. There's a lot of Greek letters in trig in general, but this is the one that we're going to use today. Is that okay with everybody? Everybody understands what that symbol means? It's just like an X, but it's called a theta. All right. Very important, and I had you hopefully address this already, but the mode of your calculator matters, and it matters only when you are touching sine, cosine, and tangent buttons on your calculator. If you are not touching sine, cosine, or tangent for a problem, it doesn't matter what mode you're in, okay? So don't get all worked up. You took a whole test and you're like, I was in the wrong mode. Okay, but if you weren't doing sine, cosine, or tangent, it doesn't matter. Now, just to check that we're all in the right mode, let's everybody push the sine of 30, and you should get 1/2. Or 0.5. Everybody good? You didn't get that? Who said that? Okay. Jack, do you know how to help him make sure that he's in degree mode? It's the mode button right up here, and then you want to go down to degree. Now, on my calculators from the back of the room, it will tell you at the top, as soon as you turn the calculator on, it says degree up here, but some of the older ones don't do that. Everybody good? Did you get it fixed, Elijah? Okay, everybody else good? All right, this is some basic vocab that you need when dealing with right triangles. Everybody's gonna know that there's a right angle somewhere. And then there are 2 acute angles that total 90 as well, because the whole thing totals 180. Everybody good? All right, what we're going to need to know today is that the side across from the 90 is called the hypotenuse, and I'm just going to abbreviate like that. So this is another hypotenuse. If we turn it this way, this would be the hypotenuse. Everybody good with finding where the hypotenuse is? Okay, that one has to be real easy and automatic. It does, like this picture, sometimes students get confused, but the hypotenuse is down here, right? Because it's across from the 90. Everybody good on one like that? Okay. Then we're going to have 2 legs that make the right angle. The legs are going to be named based on where we are standing or what angle we are working from. So if on this triangle I put a theta down here, if on this triangle I put my theta up here, and on this triangle I put my theta down here again, then we're going to talk about the terms opposite leg and adjacent leg. Adjacent simply means next to. Okay, so now there are 2 sides adjacent to this angle. I always draw a little smiley face down here. I'm standing right by this little theta. Okay, There are two sides right next to me, but one of them's the hypotenuse. The other one is called adjacent because it's next to. Okay, adjacent leg. And that leaves the one all the way across the triangle from me as the opposite leg. Okay, so help me out hopefully quickly. If I'm standing up here at the top acute angle on this triangle, where's opposite? There's two legs, this one and this one. Which one is the opposite? The one on the left or the one at the bottom? Okay, is that where just all we're confused what to call it? No one was answering. I was like, oh. Okay, so next to me right over here would be the adjacent leg. Everybody good? So on this triangle, if my little theta was down in this corner or my little smiley face, I'm standing down here. The one right next to me on the bottom here would be the adjacent leg. And the one clear across the triangle would be the opposite leg. Everybody feel comfortable? Opposite, adjacent, and hypotenuse. Those are very, very, very important. They'll make the whole determination for whether we can easily solve the rest of these. Okay, there are three. I'm going to review a geometry idea here. If a triangle has a 90 and say it had a 32, I'm just picking a number, okay? So I know this triangle has a 90 and a 32 degree angle. Every other triangle that has a 90 and a 32 is similar because of a theorem called angle-angle similarity. Does that sound familiar to anybody from geometry? If you have two angles the same, the third angle has to be the same and they have to be similar in size. Similar does not mean congruent, right? The lengths can be different, but they are all the same shape. So what has happened is that a triangle that has a 90 and a 32 has similar sides, and so the ratio of those sides is the same. And those are programmed in your calculator, and we're going to use that idea to find missing pieces. The functions that we're going to use are sine, and you have to say sine of an angle, and the word sine is S-I-N-E. We abbreviate it without the E, but we usually still pronounce it sine. And I'll just put an angle here. You can put a theta there if you want. The sine of some angle is the ratio of the opposite leg to the hypotenuse. I remember that by just so. I say so with a long O sound to remind myself sine is opposite over hypotenuse. Okay? The ratio for cosine of an angle is the adjacent leg over the hypotenuse. So I say ka with a short A sound to remind myself that that's the A that goes with the cosine. Okay? And then tangent of an angle doesn't use the hypotenuse. It is the only one that can be greater than 1 because it is the ratio of the opposite leg to the adjacent leg, or TOA, okay? Opposite over adjacent, TOA. Now, most of you probably learned from a teacher who taught you SOHCAHTOA, TOA, and some even put this cute little thing up about some Native American who stubbed his toe and he had to soak his toe, and it just kind of rinky-dinky. But some of you may have learned this way. On your calculator, it goes sine, cosine, tangent. Everybody looking? It always goes in that order on any calculator I've ever seen. Everybody see that? Sine, cosine, tangent? Okay, some teach Oscar had a handful of apples. Did anybody have a teacher who taught Oscar had a handful of apples? So sine is O over H for Oscar had. Cosine is a handful is AH for cosine, and tangent is of apples. Okay? Whichever works for you. You're going to want to memorize one or the other and be able to write it across the top of your paper right away. Does that make sense? So you can visually see which function you're going to use. Then what you're going to do, first we're going to just practice those ratios, I guess. So these just say write the value of the trig ratio. When you see the word ratio, it just wants a fraction, okay? Do not try to find an angle. Read directions carefully. Is everybody with me? Yours looks a little bit different. It doesn't have the lines in, but you find where we are. Okay, tangent of x. So this is a big deal. You have to be standing at x to determine this, particularly for tangent, because tangent is TOA, opposite over adjacent. So from this spot, where is the opposite leg? Can you give me a number? And adjacent leg is 9, because this was the hypotenuse, right? The longest side, or the one across from the right angle, was the hypotenuse. So O over A is going to just be 12 over 9, which we are going to go ahead and reduce by 3 to 4/3. But that's all this was looking for. That seem okay? So the sine from C means if we are standing at C, sine is what? How do you write sine? Opposite over hypotenuse, or so, okay? So the opposite on this picture is the 24, and the hypotenuse is the one across from 90 here, the longest, or the 26. So we're going to write opposite over hypotenuse, and we're going to reduce by 2, right, to just 12/13. Is that right? Did I reduce that right? Somebody yell if I do something wrong. I'm just trying to get through this with a decent recording this time. All right, so can you try these two real quick? Number 5, you're standing up at Z. Cosine is adjacent over hypotenuse. And tangent, you're standing over at X. And tangent is opposite over adjacent. Someone tell me what they got for number 5. Adjacent over hypotenuse. I got 28 over 35, which reduces by 7s, right? And would become 4/5. Did anybody else get 4/5? You do know that you can type 28 divided by 35, math, enter in your calculator to reduce a fraction. Everybody good? Did I do something wrong? Are we good? Okay, this one goes to X, and then it wants opposite over adjacent. You have to be a little careful on this picture because the 50 is the hypotenuse, so opposite over adjacent would be 48 over 14, which only reduces by 2, I think, to 24 over 7. Yes? No? Everybody okay? All right, now we are going to use those ratios to solve. Let me talk a little bit about, let's just talk for a second about the idea of a proportion. A proportion is when you set one ratio equal to another and you do the whole cross multiply and divide. Does this sound good? So if it said 4 over 5 equals x over 7, when you were in Algebra 1, they had you write 4 times 7 equals 5 times x, and then you got 28, and then you divided by 5. But when I see this now, I just think in my head, well, the x is up here, so I'm going to have to divide by that 5. I'm going to do 4 times 7 divided by 5 and do it all in one step. Does this make sense? So what if it looked like this? What would you type real fast to get that one? 9 times 3, and then you'd get 2x, or you'd have to divide that by 2 to get the x by itself. Am I making it confusing by having you do it all in one step or not? Okay, so we're going to have something like this in a minute. Just look at this little example. And you're going to type 7 times the sine of 36, and that'll just give you 1x, right? So you'll have x equals 7 times the sine of 36, and we don't need to do that. I'm just having you think about how we set these up. What changes, though, when we have one like this? When I put this over 1, what do I actually have to type? This time the 9 and the 1 are across from each other, so I get 9. And I get the cosine of 43 times x, which means I'm going to need to divide by the cosine of 43. So I'm doing the whole cross and divide by the one across from x. All right, I'll show some steps as we go and see if you can get this down to shorten a little bit. So this is what we're going to do. You may want to write a couple of these steps down if this is feeling uncomfortable to you. Most of you have seen this and you remember, but if it's feeling uncomfortable, you always work from an acute angle, and I would suggest you first label the sides from that acute angle, O, A, and H. Then you decide which function you're going to use. So are you going to do so, or ka, or toa, based on the letters that you have for the unknown and the known. Okay, which one do you know, and which one are you trying to find? The one that has nothing on it, you can't use a function that has that. And then we're going to cross multiply and divide. So I'm going to skip to this one and we'll do a little practice. If somebody needs me to go back to that slide, now that you've seen a couple and need a little more direction, let me know. So first of all, I'm going to put my smiley face at my acute angle that they gave me or that I'm looking for, which in this case is the 61. Okay. And then from there, I'm going to label everything real quick. This is adjacent leg. This is opposite. This is hypotenuse. How are we doing? Okay. Now at the top of your paper, you should have so katoa. This is asking me to find hypotenuse when I'm given opposite. Which one uses an O and an H? This guy, right? So that's the one I have to pick. This is how you determine which function. Then once I have that, I have to set it up as the sine of the angle, which in this case was 61 degrees, equals, and then it's opposite over hypotenuse, so it's 15 over x. Right off the bat, we have an icky one because the x is in the denominator, so we got to do a little work here. If I make this a proportion by putting this over 1, I cross multiply this way and I get 15. If I cross multiply this way, I get x times the sine of 61. Now, I probably wouldn't write that on my paper because I would know right away I need to do what? Divide by the sine of 61 to get the x by itself. So I usually just write 15 times 1 divided by the sine of 61. So to get x, this is what we are typing in, and then we're going to round to the nearest tenth. So we're going to go 15 divided by the sine of 61, was it? Did I remember it right, guys? Now, because you are doing this at the end, you actually don't have to hit that close parenthesis. It's the same thing. It knows when it's at the end. So I'm going to put down 17.2 because this is a 1, the 5 will round it up. I wish these had a unit of length, but they don't. Is this a reasonable answer? Well, it's the hypotenuse we're looking for, so it should be the longest side. Did that turn out to be true? Okay. Anybody lost? I did have someone second period who said they got the wrong answer because they typed sine of 61 divided by 15. Division, the order matters, right? Is everybody good on that? Like one pizza divided among 2 people is not the same as 2 pizzas for 1 person, right? Okay, so we got to think about dividing this in the right order, and it was 15 divided by the sine of 61. Okay, on this one, where am I putting my smiley? Next to the 67 here. Where's the hypotenuse? Hypotenuse is down here on the bottom. Opposite leg is over here. Adjacent leg is next to my smiley face. So I don't know anything about hypotenuse. I have an x and a 16 that are on opposite and adjacent. Therefore, opposite and adjacent indicates I need to use tangent. So I'm going to write the tangent of 67 degrees equals opposite over adjacent, which would be x over 16. All right, then I am cross multiplying. So I'm going to multiply these two together, and that will give me 1x. So I just get x equals. Now, there's a trick here. I'm going to write 16 times the tangent of 67, or at least that's the order I'm going to type it in my calculator. Let me show you why. If I type 16 times the tangent of 67, did I remember the numbers right, first of all? Yes? Okay. It doesn't matter the order that you multiply things. So you could put tangent of 67. What makes it an extra keystroke is this only works if I do what? Close the parenthesis and then do times 16. Do you see what I'm saying, guys? It's the same thing, same answer. I just like to leave this tangent of 67 off at the end, then I don't have to close the parenthesis. That's just me being lazy. All right, so I'm going to write 37.7 as the length of that side. Now, is that reasonable? Seems like it could be okay, right? It definitely looks like it's the longer leg, but we don't know the hypotenuse. Okay. How are you feeling? Can you try a couple on your own? Turn around and talk to somebody behind you if you're stuck. So from this angle, I'm looking for opposite and I know hypotenuse. From this angle, I'm looking for hypotenuse and I know adjacent. Is there anybody who really is struggling with this? I feel like they don't remember. You won't be known on the video. I just want you to wave at me so that I can know you're struggling a little bit. But okay. Did everybody figure out that 11 was sine? And then on this one, I'm just cross multiplying 17 times the sine of 24, I think, right? Anybody else get 6.9? And that seems reasonable. It looks like the shortest leg over here. It's shorter than the hypotenuse, okay? This one I have adjacent in hypotenuse, which is cosine. What makes this one a little tricky is that the x is the hypotenuse, so how am I going to type this in? I have 13 times 1 is 13, but then I need to, this is with the x, so I need to divide by the cosine of 73. Do I need to write out more steps? If you cross multiplied, you'd have x times the cosine of 73 equals 13, and then you would need to divide by the cosine of 73. I just don't usually bother to write that out. So 13 divided by the cosine of 73. I got 44.5. Anybody else? It should be the longest side in the triangle, but definitely bigger than that 13. So we're good. All right. There are a couple more here, but are we good? Can I skip these? Okay. The next possibility, oh, there's 4 more? How about we just write down what function it would be? Can you tell me without even writing anything maybe what function this would be? This is adjacent and hypotenuse, right? This would be a cosine. What about this guy? Opposite and adjacent would be a tangent. 15 would be, this is a hypotenuse, this is Opposite, so would be sine. And what about this guy? Adjacent and hypotenuse would be cosine. Everybody okay? Do you need me to do another proportion or two? Okay. The next idea we have is to find an angle. You do these no different until you go to the calculator. Because then when you get to the calculator, you're going to have to tell it, I already know both of the sides. I need an angle. So you're undoing the ratio. So we're going to use the second button on the calculator. We are going to use inverse of cosine or second cosine if we have adjacent over hypotenuse. We're going to, I should have done sine first, sorry. Second sine would be opposite over hypotenuse, and tangent would be opposite over adjacent. All right, I could spend more time on an example, but I really think that you'll get this if we just go to the problems. Anybody need more time? You good? Okay, this is going to give us the angle in degrees, okay? So if we jump to number 18 here, I have an unknown acute angle I'm trying to find. The 19 would be called what? Anybody awake out there? What's 19 called? To that angle, it would be adjacent, and the 28 is the hypotenuse, okay? So this again is at the top. So we have adjacent and hypotenuse, which means we're going to use cosine. Now, we have a cosine of some unknown, I'm going to call it theta, and that ratio is A over H, or 19 over 28. So you can write that step like this, but to undo that, you say I'm going to inverse cosine that fraction 19 over 28, and that will give me theta. Okay, so you can just leave it like this, or you can write it like this. I'm not going to be picky, but you do have to remember when you go to your calculator that you're hitting second cosine, and then to put a fraction in, we just use the division symbol, so we have 19 over 28. And then it gives us 47.3 degrees. Or 47 degrees. It says nearest degree up here. I can't remember what delta math does, if it does to the nearest tenth of a degree or to the nearest degree. So I'll do both today. Number 19, if I put my smile where the question mark is here, or my theta is here, what function do I need? This would be opposite. This would be adjacent. I don't know anything about the hypotenuse here, so that's not going to help me. The only one that uses only opposite and adjacent is tangent. So I have the tangent of the angle is opposite over adjacent. So I'm going to type it as the inverse tangent of 9/25. This is when you are finding an angle. Okay, to find an angle, you always have to use the second, then the tangent, then this was what? I already forgot the numbers. 9 over 25. So I got 19.8. Or to the nearest degree, it would be 20 degrees. How are we doing? You need more, or can you try the next two on your own? Let's see, from this angle, opposite and hypotenuse, this would be a sine, right? And this guy would be opposite, same thing. Yes? I got 71.8 or 72 degrees for that first one, yes. And is that 26 over 54? Can't read my handwriting. 28.8 or 29. Like I said, I usually on a test or quiz say to just give everything to the nearest tenth. I don't remember what delta math does for these angle ones. All right. The next thing we need to talk about is the whole next worksheet. We're going to get through these patterns of special right triangles. I don't know if you remember this from geometry. If you just came from Trig, you did enough of this that your brain is falling out of your head. But the special right triangle stuff is the 30, 60, 90, 45, 45, 90. So important for this course. This is exactly what it looks like on the SAT. They give you the patterns, okay? You take the SAT, these are all over it, but they give you this pattern on a formula sheet. That being said, you don't get a formula sheet for pre-calc. For this, you get one with lots of stuff, but it doesn't have this. So you need to memorize these patterns. Let me go over real quick. The pattern for a 45, 45, 90 is this leg and this leg. Okay. I usually call these X and X. So maybe I'll just go back to using that. But if these are X and X, then I'm trying to find this hypotenuse. Well, if I did Pythagorean theorem, I'd have x squared plus x squared equals hypotenuse squared. Everybody with me so far? I'm just showing you where this comes from, guys. What's 1x squared plus 1x squared? 2x squared is equal to the hypotenuse squared. How do you get the hypotenuse all by itself? You got a square root. What's the square root of 2? Well, it's some like 1.4 number. But what is the square root of x squared? Just x, right? It would normally be the absolute value of x, but if we're talking about a triangle, we can't have negative numbers. Okay, square root of hypotenuse squared is just the hypotenuse. So this is the pattern. This is where the pattern comes from. The legs are the same, and the hypotenuse is whatever the leg is times the square root of 2. Now, they're going to do some really mean stuff with radicals on these, okay? But the most basic kinds will just look, can I go to the next slide? The most basic kind will just look like this, where you have a 45, 45, 90. One leg is 14. This is another leg, so it's also 14, and the hypotenuse is 14 square roots of 2. Or if the hypotenuse is 7 square roots of 2, when I take the square root of 2 off, I get 7 for each of the legs. Does that seem okay? If you memorize that pattern, that's all that's happening on those. Unfortunately, they get trickier because they don't always have this little easy peasy pattern thing going on. Well, they do, they just hide it. Okay, if this is a 45, 45, 90, where's the other leg? Or I should have said, what is this? This is a leg, yes? So the other leg is y, okay? These are both the legs, so they are both square root of 10 over 2. Everybody okay so far? Then it gets a little trickier because this is a hypotenuse, and that hypotenuse should be the length of the leg times the square root of 2. Unfortunately, you can't just leave that. All right, that becomes the square root of 20. How do you simplify the square root of 20, guys? You got to have a perfect square that goes in there, which is 4. The square root of 4 is 2. And then what happens? Yeah, this 2 divides by this 2, and we're just left with a square root of 5. Now, this is the length of a leg times the square root of 2. It's just in disguise. You don't recognize it. Okay? This is also one of these legs times the square root of 2 somehow became 2 on this side, right? Either of the legs times the square root of 2 became a plain old 2 on this picture. So what do we need to do? How do we solve for m? Divide by square root of 2. Can we leave the answer that? I wish we could. I don't make the rules, but we can't have a radical in the denominator. So the rule to get rid of a radical is to basically square it or multiply it by itself. Now we can't randomly square because that'll give us a squared side. So we multiply by square root of 2 over square root of 2. You need to know that the square root of 2 times the square root of 2 is just 2. Square root of 2 times square root of 2 is 2. Square root of 75 times square root of 75 is 75. Square root of pi is times square root of pi is pi, okay? You're multiplying it by itself, you're squaring it, it's just the number. Now up top, 2 times the square root of 2 is that. Then what happens? Yep, and I'm just left with square root of 2. So I have square root of 2 and square root of 2. That feels wrong, doesn't it? Because the square root of 2 is supposed to be on the hypotenuse, but it's in disguise on this problem, okay? All right, we're going to talk about the other pattern that you need to know. The other pattern comes from a 30, 60, 90, which actually comes from an equilateral triangle. You all know this guy, 60, 60, 60, okay? Now, if I called these all x, then I would have a 1/2 x and a square root of 3 over 2x, and they decided that was too fancy or hard of a pattern. So they called these all 2 or 2x. Because when we split this in half, when we draw this line down the middle and split this into a 30, 60, 90, now what does this become? What is this chunk going to be? This is an x, and this is an x. That seem okay? Now, this is again where we do that crazy Pythagorean theorem thing. If I had this leg, which is x, and I squared it, and I added this leg down the middle here, because I'm talking about this triangle right here, I'd get the hypotenuse, which is 2x squared. Now be careful. What is 2x times 2x? 4x squared. If I subtract an x squared from each side, you don't really need to write all this down, I'd get a 3x squared, and then I'd square root each side. And I'd have the leg equals the square root of 3, square root of x squared is an x. That's where that pattern comes from, okay? That's why it works. It's from Pythagorean theorem and the fact that you had an equilateral triangle. So it's x squared plus leg squared equals 2x squared. But 2x times 2x is 4x squared. We subtracted one of the x squareds over to that side. That left 3x squared, and then we square rooted it. So the pattern is this leg is the short leg down here, x, times the square root of 3. So this is the way I remember it. I think of as short leg is x, hypotenuse is 2x, and long leg is x square roots of 3. What will help you is if you know the square root of 3 is less than 2. Type it on your calculator real quick. Square root of 3. And square root button, second x squared, type of 3. 1.6 something? Is that right, or is it 1.7? 1.7. Okay, but do you understand that it's less than 2? Because the most common mistake is people put the square root of 3 on the hypotenuse because they're like, it's a 3, it's a big number, it goes on the hypotenuse, it's the longest side. It's not, okay? Square root of 3 is less than 2. That will help you remember that. Okay, so we are going to move to this problem. So normally if we drew our 30, 60, 90 this way, we'd have the short leg, the hypotenuse, and the long leg like this. Okay, I'm just drawing it in this same way. So they gave us 7 square roots of 3 on the long leg. I'm going to write LL there for long leg. So we take off the square root of 3 and we'll be left with what? A plain old 7 that belongs on the short leg down here. Yes or no? And to get from the short leg to the hypotenuse, they say we should double it. So that would make this side 14. We okay? Abe, you with us? Okay. Over here, this one's even easier. The picture is going the same way. So we have a leg, square roots of 3, and a hypotenuse. If this is a 4, what is side A over here? If we know the short leg is 4, then the hypotenuse is 8, and the long leg is 4 square roots of 3. You have to leave these in exact radical answers. You can't just use Pythagorean theorem in your calculator and some trig, okay? Because you'll get decimals. All right, number 9. All right, this is a little painful, but it's not as bad as some. If we have this idea, this is your x, this is your long leg, x square roots of 3, and this is your 2x on your hypotenuse. So if I know the hypotenuse, what do I need to do to get the short leg? I need to take and divide it by 2, yes? So that would be 11 over 2, or I suppose you could use 5.5. And where would that go? Is it the x or the y on this picture? So the y here, the short leg, I'm going to write 11 over 2. If you wrote 5.5, I wouldn't count it wrong. All right, so to get to this side, we're going to do 11 over 2 times the square root of 3, which can also be written 11 square roots of 3 over 2. Either way is fine. All right, this is the really gross one. Hang on with me. This is supposed to say the short leg, which is v, times the square root of 3 is suddenly listed as 13. So what do we have to do? I'm going quick, but we got to divide by the square root of 3. All right, we will spend more time on this tomorrow. This is the homework tonight. It's a Delta Math. Does anybody, guys, if you go to the new Google Classroom, which I think you've all joined, look what I did under the lesson plans. Okay, I made it really easy. Look down at the bottom of the lesson plan. Here's the link you click on to join the 5th period Delta Math class, okay? I put it right in the lesson plan. All right, if you can't finish because you're having trouble with some of those special right triangles, we'll do some more tomorrow. Thanks for being patient with me.